Hey everybody, this is Larry, this is me going Q3 of the weekly contest 436, Partition a way to minimize XOR. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one I thought it was, honestly, for me anyway, relatively straightforward. It's definitely not easy, just to be clear, but you know, Leetcode gives you a lot of dynamic programming problems, and as a result, yeah, I mean, you just get practice into it. The only tricky part is actually that n is equal to 250. N is equal to 250. My solution is, to be honest, n squared times k, which is 250 cubed. And also, honestly, it was a little bit of a YOLO. I wasn't confident about it in terms of time limited it. And I was already ready to change to use another language where I know that it'll be fast enough. But the reason why I didn't is just because I YOLO submitted and it accepted before I changed it to another prompt. And I was going to show you this, but I don't know why it takes so long to load. But yeah, my submission. But TLDR, and it shows up, okay, it took 18 seconds, which is not what I would have expected, honestly. I would have expected it to time out at much earlier. But in any case, but getting up around Leetcode things, because I think, honestly, this is why I don't do live contests anymore, because Leetcode has, at least the prompt writers, have shown that they do not understand their platform. Okay, I mean, the reason why this takes 18 seconds is time limited versus other platform is that on other platforms, on many other platforms, your test case or your execution time for time limited is based on each test case, right? And you take the max out of this, or maybe another way to say is that if one of your test case times out, then it times out. But each test case has its own individual timing. But for Leetcode, they just kind of aggregate all the test cases together. And as a result, there's just no way for you to know when you submit it whether it's going to time out or not. Because if it's on one test case, you could test your max case on local computer and be like, okay, or just submit it or run it on their machine for one test case and see how fast it would be. If it's too slow, then you do optimization and so forth. If it's not, but otherwise, in the execution time, you know, my code took 18 seconds, but if, I don't know, let's say there are 100 test cases. I don't know how many there are, but let's say there are 100 test cases, but I don't know exactly. I don't know how many test cases there are. So if there are 50 test cases, then my code would go from 18 seconds to 9 seconds, which is fast enough, right? So I don't know any of these inputs, and it's not even like it's input sensitive in that, like, oh, there's some like weird inputs that make it slow. No, it's just because I don't know how many inputs there are. And you can, you know, if I said there's 100 inputs and it takes 20 seconds, you can have 200 inputs and it takes 40 seconds, and this would still time out. I have no way of knowing. The only way I have to knowing is YOLO by submitting. And then the worst case about that is that if we time out, what does that mean? I don't know, right? Because if I optimize 10% away, is it fast enough? Well, if I go from 10%, if I go from 11 seconds to 10 seconds, maybe that's fast enough. If I go from 22 to 20, maybe that's still not enough. And definitely if I go from 44 to 40, that's not fast enough, right? So 10% difference, is it fast enough? Another YOLO. So many YOLO, so many uncertainties, so many questions, right? And this is where, you know, I mean, the limitation is fine, and this is too much of a rant, feel free to skip for it. Some limitation on the system is fine, but as prompt writers, you have to accept that. You have to know it. You have to recognize this is the constraint you're working with. And this is where the n is equal to 250 is really dumb for a prompt writer. This problem is fine by itself, but n is equal to 250 tells me that the prompt writer just sucks as being a prompt writer, right? Because they do not understand the limitation of their platform. If this is on a different platform, maybe they tested it, maybe it's fine, right? But on Leetcode, this is not the case. You have to understand your platform, you have to understand the limitations, and maybe some parts of it is that you have to be a competitor first in other languages or something. I don't know, right? Whatever it is that they're doing, it's not working. And the ultimate sin is not even that it's 250 or 100, even though, you know, n cubed for 100 is a million, for 250 is 15 million. So this small change means that it's going to be at least, there are other things as well, but at least 15 times slower, right? Which is just like unnecessary, because if you look at this problem, as a problem writer, I would ask, what is the difference between 100 and 250? Or is there any differentiation that you cannot get from 100 and 250, right? Is it because you're trying to eliminate people doing n cubed log n or something? I don't know. Maybe that's a thing, but you get my idea, right? It's not a new problem, or it's not a different problem for n is equal to 250 or n is equal to 100. So then if that's the case, then what is your goal? What is your point? Why are you doing this, right? And anyway, maybe I need to cut this to a different video. But in any case, that is why this problem is a very dubious problem. And my apologies for the rant. It's just kind of a very silly problem as a result. But otherwise, this problem is nice, it's fine, but it's not interesting. The only interesting thing about it is how poorly the problem writer has written this, right? The idea behind this is just chunking it, right? And we'll show. I mean, this code is small enough to fit on. I don't know if they changed the font or something. It's kind of weird, but like I feel like I have 25 lines of code and it barely fits all in. But in any case, yeah, without taking the max, and I had some typos, which is why it took so long. But 25 lines of code is the entire problem. So this is a, you know, I wouldn't say straightforward, but it is practiced, right? Because I have practiced a lot on similar problems, because Leetcode, it does come up a lot in Leetcode, right? So, and I delete some debugging line, this is it. So the idea here is that, okay, you have index. So you have index goes from 0 to n, right? And this is the beginning of the next, I call it chunk, I don't know. Maybe they call it partition, I think. But yeah. And then left is how many partitions, chunks left, right? And that's it. And then from here you go, okay, well, this chunk can have length 1 length, 2 length, 3 length, dot, dot, dot. And that's what this is kind of for, though not directly. And you could calculate the subsegment chunk by using this XOR, right? By just kind of almost like a rolling XOR. And yeah, and then the cost function may be the tricky thing about it, but basically it is the max between all the other segments and the current segment, right? This is all the other segments, and this is the current segment of all the other suffix segments, to be clear, and this is the current segment. And then we take the best out of all of those current segments, and then that's it, we return. And that's honestly it, right? You start with the first index at index 0, and you have k chunks left. Yeah, just brute force number of chunks. And then of course you have to take care of some edge or base cases where you get to the end, but you still have chunks, or you don't have chunks, then it's 0. Otherwise you have chunks, it's infinity. If you don't have chunks left, but you have indexes left or elements left, then you return infinity. And what's the complexity here? Index goes from 0 to n, left goes from 0 to k. There's a 0 to n index range here, so total is gonna be n squared k. Pretty, you know, like everything's, you know, I mean, what can I say about, you know, I mean, this is not, this is 6 lines of code. It's a very tight 6 line of code, but it's still, you know, it's still 6 lines of code, right? So it's pretty, I wouldn't say straightforward, but definitely, like it's not straightforward, but if you strive to be good at Leetcode and interviewing, I would say you should get a problem like this to a point where it is straightforward, because I think this is where the bar is at for competitive programming anyway. Maybe interview is a little bit lower than this, but you know, like getting good at these problems will be, you'll just be more comfortable, right? And that's all I have for this one. Yeah, I think most of this video is me ranting about it, but I still feel strongly about it. So I don't know. That's all I have for this one, though. Let me know what you think. Thanks for watching, and yeah. and you could watch me solve it live during the contest. Next, I made 2 silly mistakes that made it 10 minutes. One is that I have a typo in Fmax, so which I didn't look into until much later because I just never, very rarely did I make a typo on these things. And then the other, what's the other? Oh, for some reason I had this from 0 to n. I just kind of messed that up, and I was getting zeros, and I was just so confused. But that's it. But the idea I had, I just kind of had some weird typos. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve this live during the contest now. Let's actually get started on this problem. We're already way behind. All right, nums, integer k, partition nums into k non-empty sub for each subarray, bitwise XOR, minimum possible of the maximum XORs. Okay, you have 250 and minimum value of the maximum XOR. I mean, I think it's binary. I want to say it's binary search. But I mean, it's either binary search or DP or both. I think DP is enough. But I guess we'll see. So we have go index. XOR is a little bit trickier though. No, you don't need the input. You just need an index. Okay, fine. Maybe. Don't know if this is true. But oh well, we need k. So okay. So we have left, right? So yeah, if index is equal to n, then if left is equal to 0, then we return just 0. Else we return infinity to infinity and beyond. Otherwise, I guess 250 square. 250 cube is a little bit faster or slow though. Even if a lot of them are not necessarily possible. I think in this one they are very much possible though. I don't know why they choose 250 square or cube rather. I mean, maybe it's fast enough, but it's still like maybe you need an optimization, but it's hard to tell. I feel like in other languages maybe you don't need to, but for Python you probably do. Yeah. Yeah. So then now we have current is equal to num sub, or maybe just 0, and current to num sub I, right? You have go I plus 1, left minus 1. I think that's the basic thing, right? If left is equal to 0, then we also return infinity, by the way. But yeah, otherwise we want the min. Well, okay, I see. Is that how am I writing it? It feels awkward today. How did I write it last problem? Okay, no, that's right. I'm just having a mind blank for a second. Okay, so then now this is, we want the min of these, but it is going to be, okay, so oops, best is equal to 0 maybe, or maybe infinity actually for impossible. So now we have f min. So we want the min coming from this, but max of either this or the current structure, which is current. Right, so best is equal to this, and then we just return best. Right, and then we can, and then that's it really, right? So 0k. All right, well, maybe not. how do I break it off? No, this is how I break it off. How does everything return 0? Okay, well, one of the answer is actually 0, but how did... Okay, 1, 2, 3, how does that return 0? Did I miss something? Oh, F max... No, that makes sense. This is either this or that. Okay, well, don't have anything. Now to try, is it just always 0? It's always 0. Why? Is this always 0? No, but it does happen 0 enough. Why? Okay, 0, 0. Why is that 0, 0? What does that mean? Index left I. Okay, so 1 index 2 partitions. Oh, it's because I have too many partitions. This is the number of cuts, not the number of partitions. Okay, still wrong, but I think this is much closer. So for the first input, you have 0. Only make 1 cut, right? No, I had it right the first time because I cut at the way. It's 2 partitions, right? No, this is right because this should go here. Okay, and why am I doing it wrong though? Okay, so 1. Okay, this is 3, but then the infinity. That's not right because current I'm just struggling today a little bit. Okay, 1, 1, and 2. What's the 2 mean again? 1, 1, it goes to 2. Okay, let's actually step back for a second. We have 0, 2. 0, 2, we go to 1. 0, 2, why not we go to 0 though? Why is there no... Oh, no, this is the 0. No, this is no 0. Why is I never 0? Oh no, this is the 0. Okay, so then now you have the recursion is 0, which is wrong because it goes to 1, 1. The infinity, infinity, 1, 1, 2. But 2 XOR... Oh, no. Oh, I'm dumb. Why is this going all the way? This should be from index. Oh man, what a silly mistake today. Okay, I mean it's still wrong, but that is just really silly. How do I blank that out? Some days. Okay. So 1, 1, 2 is still 0. Is that true? No, it should be... Oh. No, I mean this is 1 and that should return 1. So that is fine. Zero to 2 is infinity. So then why? Huh? Okay, so far it takes the max of the last 2, so I think that the states make sense. So then why is this not giving me the right answer? Or why is it returning 0? Why is that returning 0? Best, okay, I guess we just should update best. F min, the best, okay. Yeah, I mean, I think this is right. Best is 0. Why is best all 0? This should be infinity. Do I have best is equal to 0 somewhere else? 0.2. Why is this 0? F max of these two. Am I just like my understanding is wrong? Like I don't know how to read code, which is possible. Might be. Alright. But oh, is my F max wrong? Larry, you idiot. This is what happens when you write your own code sometimes. Okay, 120. Okay, that looks good. That looks Gucci. But is it fast enough? I think that's the biggest thing. I mean, this is such a comedy of silly errors. Like I don't know. 250. Is this fast enough? It looks fast enough-ish. So let's YOLO. Is it actually fast enough? I don't know, honestly. But yeah, this is a way sloppy because I had so many silly mistakes. Well, this one is the worst of them. But and it looks like a timeout, and I have to convert this to using ChatGPT to Java or something. Oh, it got accepted, which is actually surprising. Okay, I don't need to. But yeah, I mean, that should have been like a 3-minute problem, but instead it took almost 10 minutes. So that's actually very sad. Maybe not 3 minutes, maybe 5 minutes. But I was talking a little bit in the beginning, I suppose. But just a lot of silly mistakes or silly like delays. I didn't get any wrong answers, which is good, but still. I guess 5 minutes is worth one wrong answer, so it's not so bad, but it's still not great. All right, let's take a look at. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.